Hello everyone and welcome back to the FSR Policy Briefcase with me, Leonardo Meus.
And me, James Nebo.
This time we are also very happy to welcome two of our colleagues. We have Andris Piebalgs, who is a professor at FSR, and we like to say at FSR that we are academics that are close to practice, and then we also have a few academics that actually showed that they are also able to work in practice, and we have, like Andris, with an exceptional track record as a civil servant. He has, for instance, been the EU Commissioner for Energy as well as for Development, and now he is here with us as a professor, and he likes to work with researchers, and one of these researchers is Maria. Maria used to be fully based here, now she's still connected, but she's also in Oxford, contributing there as a research fellow and doing a PhD currently. We even have something in common because we didn't really study fully engineering, but we went to do a PhD among engineers. So maybe that's not for this podcast, but maybe we can have some exchange on that, on how to survive in an engineering department. Okay, so you already know who we are, but maybe also to say why they are in Florence today. So today we actually had a new course for executives on hydrogen, and I think we've all had a very interesting day here today, but we're not going to discuss hydrogen specifically. We're going to discuss a new paper, both by Andris and Maria together, and the paper is titled Decarbonization of Maritime Transport, Navigating Between a Global and an EU Approach. But actually, it's also an excuse to have here a discussion that is a bit broader than that latest paper, because in preparing this conversation, James and I had a look at everything you did, which is cover the basics you did for FSR. You also did a topic of the month recently. You have been blogging. You also did an FSR debate, which has a recording online. And we wanted to come back to some of these issues, but also ask a bit broader questions, right? For a broader audience to get into this topic. That's it for the introduction, so I think we can start with the questions.
Yes, indeed. I think from my side, Maria and I used to even share an office, but before that I was already familiar with her work when I was working at DG Energy on the methane strategy. I was reading papers from Maria and Andris. They've been working together on this topic for a long time, not just on shipping. This is more of like a recent move, as I understand it, but on various issues widely within this sort of space, if I can say that. And today the show will be loosely structured in two parts, right? So we'll do the first part on methane and its relevance as an issue, what's going on with the regulation and so on, and then we'll try and make the bridge over to shipping. I'm sure there's a bridge ship joke in there somewhere, but anyway, there's a pun already in the paper, actually. You have navigating in there. It's not by mistake, right? Navigating in the title of the paper, it's not by mistake. Anyway, so I'll assume that our well-read and informed listeners know that methane is a greenhouse gas, but some may be surprised to hear that is the second most problematic greenhouse gas after CO2. It's responsible for roughly 30% of the rise in global temperatures, and on a short timeline, it could potentially even be more significant than that, given that it is what you would call a short-lived climate pollutant. So it does most of its warming in the first years being emitted and is relatively quickly converted into CO2 and water vapor when it reacts with ozone in the atmosphere, right? So in terms of an emissions split, we see that waste is roughly 20% and then agriculture and energy relatively evenly divide the remaining 80%. So think of methane coming from decomposition of organic matter in landfill sites, the digestive emissions of ruminant livestock, largely cattle, and then fossil methane escaping from coal mines, as well as natural gas itself, right, which is predominantly CH4 methane. So, I don't know, perhaps Andris, you could begin by explaining to listeners where we are with the implementation of the EU's methane regulation and why you and Maria became interested in this maritime sector specifically.
Yeah, well, I think now after the European Parliament yesterday has supported the methane regulation political compromise between member states and European Parliament, a head of environmental committee said, now we are closing the gap that we have had in our environment and climate policies. Methane was neglected for far too long. The good news are that Parliament has supported this regulation with huge majority. And when the regulation came to the Parliament, they have been a lot of doubts. Do we need this regulation at all, and what it is all about? So Parliament has also gone through very steep learning curve. And the reason is very clear that methane emissions are 30% of cause for global warming, and for whatever reason it was neglected. One reason is that they have been not so much scientific measurements. That was one reason. Second reason was assumptions that you can phase fossil fuels very quickly out, and then you don't have this methane emissions from energy sector. And it's not only EU that has neglected, it is a big part of the world. US and Canada definitely did more. Norway has done, but in many countries they are discovering only this. So why particularly shipping? For many reasons. One is already in an article, because EU is only part of the world, but global warming is covering everything. And maritime, or also aviation, is something that connects Europe, but where we are only one of the parts. So if you try to regulate something, what impact it makes on others, and what impact it makes on you. So I think from this point, EU regulation on methane is very interesting. Another issue, it is just our pride. Because some time ago, we here in Florence School of Regulation very much wanted that methane is recognized in the ETS. And we got a huge debate here, but there was, with except of FSR, everybody was said, no, that's not the way to go. And now it is in maritime regulations, it comes in. So what could we learn from it? Could it go in other directions? And last but not least, with due respect with this energy transition, we will continue to depend a lot from maritime trade of energy resources, particularly natural gas. And there have been trends on LNG shipping and LNG brought to the EU for our security of supply. What impact it will make on our energy security and on our bills. So these have been the main reasons why this maritime is so interesting, so difficult, so challenging, and methane is a good indicator.
I'll follow up with a question, because indeed, when reading your paper, I thought it was really interesting that you said, okay, methane emissions are now included in the EU emission trading scheme, and that's sort of new, but I think somewhere in your work I also read that you said that methane has already been treated in a cap and trade system in other places in the world. So can you maybe explain that a little bit?
According to the latest research, so it was published in last year, actually methane is already covered under roughly 7 ETS systems, and part of them are subnational. So think about places like California in the US, and also the province, like Quebec province in Canada. And there are 3 systems at the national level, so New Zealand, South Korea, and Switzerland. And in most of the systems, they include methane emissions from the energy system and also industrial processes. There are also like South Korea and New Zealand, which include emissions from the waste sector. And some ETSs also include the so-called like the offset schemes as well. And this is again the case of, for instance, California and Quebec that allow, the methane abatement projects to count under these projects.
We'll get into the IMO, this International Maritime Organization, and their regulatory environment a little bit later on, I think. But I think first, just staying with the pure methane regulation, I understand it's covered, of course, the methane regulation itself, now ETS, and perhaps elsewhere. I mean, do these sort of different regulatory environments create issues already? I mean, do you have some examples of this?
Yeah, there is definitely challenges coming out because methane regulation is going slightly in one direction, and then maritime is going in another slightly. There is issues of where you take from wake to wheel or from well to wheel. So it's a lot of inconsistencies, and it perhaps could make a challenge. But it's good to recognize them and to take into account when you apply this. It's important that methane is part now being addressed. I think that it is the most important. So it doesn't create some things that you would say existing adopted regulations will be not non-effective, but we need to know how its overspill is going and also what impact it will make on commercial operators. I think that is something that we still need to go more in depth because for them it's a new challenge. And as always, when you are a regulator, you go rather simple way. Well, who imports needs to solve the problem, but you need to look also at the whole value chain. And that makes things a bit more complicated. Also, maritime is also a very complex sector. It's not that, all ships are owned by one company. There are many different companies. Their status are different. There is leasing. There is a lot of different issues because what we care that greenhouse gases are abated with less possible costs for society. That's what matters. And we need to follow how these regulations will deliver on it.
Maybe another look at this question is about the quantification of emissions, because I think that becomes even more important with the adoption of the EU methane regulation, which should happen, we expect, around June this year. I think what is really important in that case is that countries have different approaches to how to mitigate emissions. But I think they need to somehow some sort of understanding of how to measure them and quantify them so that we can compare how much EU is doing versus other countries. We have also the Global Methane Pledge, so the commitment to reduce methane emissions from all anthropogenic sources by 30% by 2030 compared to 2020 levels. And now the question is, what are the 2020 levels? There is a lot of uncertainty in terms of the inventories that we have currently. And I just want to mention here 3 initiatives when it comes to the MRV of methane emissions that are the most, let's say, mature or the most significant. And here we have the MRV system that was recommended by the European Commission and European Union in general. So, and it was included under the methane regulation. So that was the voluntary OGMP 2.0 framework. And apart from that, we have also initiatives coming from other regions. And here we have one initiative coming from the US Department of Energy. It's called MRV framework. And we have the third one coming, the so-called Clean initiative coming from Japan and South Korea. And they have also started to collect the data from the LNG suppliers. And again, we don't know exactly, we know that there are differences between these approaches. Especially we see the differences between the EU approach and the US approach. And now the question is what happens next, right? Whether we will be able to find an agreement on one system for the quantification of emissions and how it will work in practice. I think that's an important question.
Very interesting. You talked already about monitoring, verification, and all these issues, I think, come up several times. So I think there is some, as you said, frameworks in the US, in the EU, and then I learned also that there are default values sometimes, but then there is actual measurements, right? Is it true that your supervisor even or your team was on a boat to do some actual verification? I learned that in the debate, which maybe you can say a bit more about that, but then there is also satellites that can play a role. Can you explain us a bit more how satellites are used? What are limitations maybe? Or
I think before going to measurement is one particularity of methane emissions. Normally you would assume you cut gas consumption by half and methane emissions should be cut by half. Like with CO2, you'll use less, and unfortunately with methane by far more complex. There is our so-called super emitters. Perhaps the name is not quite correct because these super emitters could be many. There is 100 kilograms per hour that are as a threshold, but there are many and they are irregular. So you basically need to measure really to understand how much you emit, and you could perhaps close a couple of fields and you get most emissions from other fields you did not expect. So you need to measure on the ground. But you also has a lot of opportunities from satellites, especially new generation satellites that definitely could get with a lot of granularity, so-called exactly how much emitted, where are super emitters located, etc. The issue is that, well, even if you see by satellite, you could change things on the ground, the operators. And this needs somehow be to put together. and operators could be skilled that they need to do some basic things like leak detection and repair, or in sometimes just to follow normal operations. Maria does a lot of work also on measuring on methane emissions from the biomethane installations, and sometimes what she tells, well, they forgot to close some valves, and then they are emitting. But basically, you need really a lot of protocol that need to be followed by industry. So it is complex, you can see, but it does not mean necessarily that you immediately also close these emissions. So yeah, it is a complex challenge, and it comes not only from energy, where normally it assumes that you could rather effectively to stop most of the leaks, but it is also landfills. And with satellites, we see by far more that landfills in many cases are having this super emitters event. And then definitely we have agriculture. And in agriculture, we still have not started really to do anything with methane emissions.
But emissions are likely to be more diffused, so I don't think maybe satellites will be of that use. Yeah, maybe just to build on what Andris already said is that I think with the adoption of the EU methane regulation and also the change of regulations in the US, we see that both jurisdictions have implemented the so-called super emitter program. So now exactly like if the satellites spot emissions above 100 kilograms per hour, the operators will be notified. So I think this is kind of like way to check what the operators are doing in case there are like super big emissions. So there will be legal responsibility on the part of these operators. So I think it's it definitely uplifts the role of the satellites. But again, if you think from the point of view of mitigation only, there still needs to be then action at the exactly the facility. So satellites are great for detecting emissions, but then when you think about exactly how to approach the problem from a more organized and structured way, you need to do a lot of work on the ground actually to make that happen.
Yeah, maybe this is an important moment to come in with a bit of clarification, for the benefit of the listeners, to say this kind of reporting, the detection aspects, the monitoring and the verification are all hugely important, of course, for the implementation of regulation. And just by the very nature of how our energy value chains, particularly the fossil value chains, are organized, much of these emissions, super emitting events, etc., are happening outside of the European Union, where the European Union, of course, cannot govern directly, cannot regulate directly and enforce directly. Therefore, these satellites have a role for sort of creating accountability maybe for certain producers that these events are going on, as well as just purely notifying them, because let's not forget that in many of these cases, this is natural gas that's escaping from source, so it's a valuable product, can potentially be sold, or could be a safety hazard where there are extreme leaks that potentially are at risk of exploding. And yeah, why it's so important to do direct measurement, which I know is something that you guys are both, feel very strongly about and are doing a lot of work on, in lieu of direct measurement, particularly on a site level and where there are, let's say, smaller leaks. I know that it's quite common to use default values, right? So you have like a certain valve or something for pressurization, and you go, okay, in general, it leaks X amount for this piece of equipment, and therefore we do kind of a calculation and assumption. For this 1,000 kilometers of pipeline, you usually see this much leak, so therefore we're doing these sort of compounding calculations where no actual direct measurement has taken place, right? And this is a nuance that I think is interesting, particularly in the energy sector, because for the agriculture sector, which we've already discussed, has as much of a share of methane emissions as energy, and we're all energy people, so there's sort of a temptation to end up gravitating always to that side of the conversation. But I guess roughly how much methane a cow is going to emit. Maybe it's a stupid question, but just on a per unit basis, you can probably make quite a safe assumption, right? But whereas with a gas facility, it's quite random, because as you say, or for a landfill site, if you just forget to shut a valve or something like this, can be huge differences. So I wonder, in the context of shipping specifically, in the paper, you mentioned that the use of default values is discussed by some actors, also maybe by the IMO. You could clarify if I'm wrong about this. And why do you see that as problematic specifically? And have you seen sort of significant underestimations in that space? And is it always practical to do direct measurement?
I think it's very broad. I will start perhaps as answering James on what you said. Yes, it's true that US and EU is only part of this global energy landscape, but there is United Nations. Under United Nations, there is a program called Methane Alert and Response System that notifies operator or governments. And so far, it worked reasonably well, so the reaction was there, and also media has been there. So you could do with this. But I believe in many things, and that's why where comes this your question on maritime. It is anticipation. Today, if you take emissions from maritime, it's not a lot of methane. But if you look in dynamic, methane emissions are growing strongly. We know that a lot of LNG propulsed ships are being built. So you need to anticipate. You need to running away from greenhouse gas emissions, not to go in new area where you again get this. And why shipping from this point is so interesting.
Yeah, so maybe just to add on that, again, I want to a little bit take a step back and explain the issue with default factors. Is that what we've seen once we started to do more measurements, especially in North America, is that there is a lot of underestimating taking place, and even the official inventories, there were studies showing that they significantly underestimate emissions. And this comes from the very nature of methane emissions. And methane is much significantly different than CO2 in that respect. With CO2, if we combust, for instance, 1 kilogram of kerosene, we know that it produces 3.16 kilograms of CO2. I know it for tomorrow. But with methane, because it comes from such a diffuse and heterogeneous sources across the entire supply chain, it's really difficult to track them. And then we have also the issue with super emitters. There are also other factors that may have some impact on how frequently methane emissions is emitted, and we have intermittent sources. So that's why there was a very clear conclusion coming from the scientific research that we need to start measuring emissions. And it doesn't necessarily mean that in the future there won't be any emission factors. It's just that the issue is that to do the measurements and then to improve the emission factors. Because there could be some significant differences between what you think you're emitting and what you're actually emitting. So this is one thing. Another thing is that some countries realize that, for instance, in Canada, they call it the so-called pie chart problem. So they have the official inventories showing the distribution of emissions across different sources. And now when they started to do the measurement, actually, the result is quite comparable. So they have more or less the same amount of emissions, but they realized that the distribution within the pie chart has changed. And I also have seen some pie charts coming from BP. They also saw exactly the same problem, is that, and from policymaking point of view, it's really significant because, you may be tackling the wrong thing. So that's why I think it's so important to include the measurements because it shows that, the reality on the ground.
And I understood from the debate you moderated that indeed the EU is starting with default values, but is then opening up to actual measurements, right?
Because default values are very simple, and especially if you include the ETS, it creates a predictability. So you definitely have some value of the default value. So there is some sense, but they need to be based on correct measurements. So, and if we take shipping, we know not enough. There is very few really measurement-based studies being done. So we really don't know too much. And if we look further away for consumption of natural gas, you need to have emissions through the whole value chain. Mm-hmm. And if you really have a lot of measurement, you most probably would apply some factors because at the end of the day, it's a huge traffic of LNG. So you need to simplify sometimes things, but you need to simplify things so that you don't get like 20 or 40% emissions more than you expected by these factors. I give you this example, 20 to 40%. It is measurement from satellites coming on US landfills. What there is being reported is actually by far less than you already now see. And that, I think, is an issue with methane.
Yeah. Related to that, so I don't know if there is an answer to this, but you mentioned in the paper that there is LNG, like we know, right? Using LNG as a fuel, but also cargo. But then you have this new development with ships using LNG as a fuel, but carrying containers. So do we already know something on where the emissions are? Is it mainly in the fuel use, or is it mainly in the storage, or where is it?
Yeah, so a Pulse study shows that actually the key sources of emissions is methane slip. So we assume that when we combust methane, all the methane should be combusted and transferred into CO2. But actually, because of some reasons, not all methane is combusted. So this is a very significant source. And I think, like speaking again about the measuring of emissions across the entire value chain, I think it's really interesting to see from the EU perspective, the shipping is not included under the EU methane regulation because it's included under the EU ETS. And then, for the methane regulation, we have the rules on the measurement of emissions, whereas for the shipping, which falls under the EU ETS, there is, the operators are allowed to use default factors. They can do the measurements, but they don't need to do that. Doing measurements, it's always extra effort. So I would assume that we will stay with default factors.
Speaking about ships, well, you say, I have ship, and what can you do? Well, I just discovered that you use, there is methane slip, and it's unavoidable because I can't get rid of the ship for next 20 years. Actually, it's not true because it's also important how you use the engine. By higher loads, there is less methane emissions. By lower load, it is a higher methane emission. So operation mode also matters. And as long as operators are paying for it and have a knowledge, they have a chance considerably reduce methane emissions and also save money. Yeah? So it makes a lot of sense. And industry, where it's always ready, at least it says always that it's ready for energy efficiency improvements. So less fuel consumed, they are more competitive. And in this particular case, both come together. We can be quite pretty optimistic that the including of methane under ETS and more attention will definitely reduce methane emissions from maritime sector.
Mm-hmm. Yeah, and maybe building on that, we also see that when there are data showing, for instance, what is happening when you look at the new order of ships. And actually, now we use, like in majority of cases, like over 90% of the fuels that are used in the maritime transport is fossil-based. But if you look at the new ship orders, it's mostly LNG. This is also quite confusing. Usually, is that in the past, usually LNG was just transported by dedicated LNG cargo ships, right? This is because the methane that during this process there is a problem with boil-off gas. And this gas can be used instead of reliquefaction. It could be used, in the engines. So that was the status quo. But over the last few years, LNG became much more popular also as a fuel for other types of ships because we have the dual fuel engines. We see this trend. LNG seems to be the fuel of choice because also when you look at the environmental regulation at the International Maritime Organization level, in majority of cases it focused on the reduction of CO2. LNG helps. NOx and SOx. LNG helps. It was not focused on, for instance, reduction of methane emissions. So that's why LNG became so competitive. Another thing that I think we discussed a little bit during today's lecture about, for instance, ammonia. There is no regulatory framework for using ammonia. And with LNG, it took roughly 20 years, to adopt the framework so that there is, consistent use and there is safety rules. That's I think, a little bit of a challenge.
At the risk of adding yet more complexity to the discussion with my last question, I wanted to know a bit more about what this International Maritime Organization is and what regulation looks like underneath it, because I think you felt similar whilst reading the paper, Leo. No, this was kind of a curiosity that was interesting because you talked, I think, about implementation of regulation from the IMO, if I'm using the quote correctly from your paper, in 2025. And as I understand it from a quick Google, it's a United Nations specialized agency, which to me then immediately provokes the question, okay, well, what's the regulatory competency? What does implementation look like in that case? And I remember I mentioned earlier that I was working on the methane strategy when I was at DG Energy, and we were working often with the Oil and Gas Methane Partnership, which was also under the UN, the UNEP. I know you both, of course, are very, very familiar with the organization. Are they similar in any way? Is it completely different? What is the regulatory competency?
Okay, so with, for instance, extending ETS to partly international shipping, EU in a way steps into the foots of the IMO. And this comes from the fact that because of the international character of emissions, they are regulated by the International Maritime Organization. One curiosity actually with, for instance, Paris Agreement is that it does not directly cover emissions from international shipping. We have like the temperature targets, right? And then the temperature targets are achieved by NDCs that all the countries need to submit. But the NDCs usually do not include international shipping, international aviation. So that's why going back to the 1997 the Kyoto Protocol, under the Kyoto Protocol, it was decided that these emissions will be tackled by these UN agencies. So it's IMO for maritime and ICAO for aviation. Those agencies in the past, they were dealing with technical issues, safety issues. So climate-related issues are a little bit new on the agenda. But nonetheless, I think just a few years ago, in 2023, the IMO adopted the new greenhouse gas reduction strategy, and they adopted also the net zero target by that should be achieved close to 2050. And that was a unanimous decision. So it's very important. It's all the countries supporting it. So when you look at the international shipping, it's IMO that regulates, because for such an international sector we need.
No, it makes sense. Yeah. It fills a necessary gap.
The challenge is so far IMO credibility is quite good. So what they have decided, it was implemented by countries, but climate is perhaps very particular. And perhaps here, I don't know if IMO regulation would be so strong as it was related to environmental hazards like with NOxes. So they made a lot of regulatory improvements in this. Here, perhaps the challenge is too strong. So I believe that what is being done in the EU to stimulate from one side IMO, but from other side, not to neglect, perhaps is very, very lightly done because on IMO organization basis, there are some limits what you could expect. But perhaps I'm wrong. Perhaps the organization will decide to be extremely ambitious and apply it, because then so far track record of implementation is good.
Mm-hmm. Yeah, maybe just to add on that, so apart from these high-level targets, we have also the different types of policies that already have been implemented. So we have the so-called short-term measures. So they are already in place, but they focus mostly on the energy efficiency. And this is the low-hanging fruit. But actually, when you look at what needs to happen to decarbonize maritime, they need to change the types of fuels that they are using. So now there is a discussion under the MEPC. This is the committee within the IMO that deals with this issue around two measures, the so-called midterm measures, and we know that they should have two components. So the technical component, which is the greenhouse gas intensity standard, and the second component is economic component and some form of carbon price. So this is quite substantial, I would say, because it could really change the game for the decarbonization of the sector.
I think there will be a lot of impact, so-called from nationally determined contributions that the countries need to submit. Methane was not very much recognized in this in previous times. Yeah. So there are two things that we could hope for. That first of all, NDCs get very ambitious, because a lot of countries, big countries, have contributed have committed by 2060 to be net zero, or 2070, Europe 2050. So I think that's one side. And second, that they really start to address methane. That would definitely help international organizations also to be more ambitious, because I think these two things are very much related. But for being ambitious, and we could make methane as a good example, from 5 years ago, I think when we started with Maria, perhaps not even 5, it was not a topic at all. And in 5 years, it made remarkable progress of dealing with this. So if there is a tension, you can do quite a lot from regulatory, also from technology point, so you can do it. But we need to see how much this opportunity will be used.
As a last question I had, I first wanted to thank you for bringing this topic to the Florence School of Regulation. I still remember, as you said, Andris, a few years ago, when you started working on this topic, everybody was always working in the research field on CO2, and then you both brought this methane emission topic to us. We've learned a lot from you. Are we going to expect something similar for NOx? Because you mentioned in your paper that in principle NOx is an environmental hazard, but it's also a greenhouse gas. So what can we expect there?
We have not done too much research. NOx is, for maritime is also under ETS. I think we will see what will reporting numbers will come and to see what is the dynamic. So for NOx, it's a guess. At this stage, it does not seem comparable by scale a problem as is with methane. So it is really produced by combustion. Methane leaks are through the whole value chain, so it is also by size, but there is particularity. It is global warming factors that for NOx is by far higher. So let's see, but we can't cover all the world by our research in Florence. So I think we will stick with methane, expecting that there will be some attention toward NOx because the problem could be by far more bigger than we know at this stage. So it is still to be discovered, but my assumption is, no, it's not the same scale problem, and it's covered well enough, because with NOx, it's extreme health hazard, also methane, but that's why it was addressed earlier, by far more earlier, by stringent regulations, etc. So they have been, I would say, by far more faster measures implemented, regulatory and others, so it is getting under more control compared with methane emissions.
And mostly in the context originally of air pollution, right? Because as you said,
Exactly.
this has an impact. I mean, diesel vehicles, probably listeners remember
Yeah.
this
So
kind of
that's
issue.
why it has been more used, and regulations decreased these emissions considerably. But for climate, it could be at some stage an issue.
But on the scale point, just quickly, when I read in the paper, maritime emissions 3% of the global total, and then the methane emissions were 0.5% of that 3%. My initial thought was, this doesn't feel like a lot, but I've been convinced by reading your paper and by this conversation today that actually, well, firstly, there's likely a significant underestimation there, and that this is definitely a problem that's on the rise. And as you rightly pointed out, Andris, given the direction the sector is going, with more and more LNG being transported, but also used as a fuel itself for the ship, it really warrants getting ahead of the game and regulating it in advance, right?
No, it's true, and whatever you have underestimated, you need to get to net zero, then you need to compensate. So it's enormous costs. You can take definitely direct air capture and expect that you could do everything with direct air, but you know that it costs quite a lot. So you would need it, but you need really to the things that you can't avoid. But everything that you can avoid, you should avoid, especially with very high global warming factors.
Yeah, also like in the podcast we focused so much on the methane slip, for instance, but we also know from how oil and gas sector operates, potentially there could be also some emissions from venting and also fugitives on the ships. It's just, for instance, the study that I mentioned done by Dr. Paul Balcombe, it's actually, it was done on pretty like new type of ship, so it was much more efficient. And, there are also like, we have something around like 600 LNG, only LNG cargo ships, so definitely there should be more studies in order to have better understanding of all the emission sources.
Okay, I think we can close here. So thank you, Maria. Thank you, Andris. Thank you, James, for allowing me to introduce and close. For what he said, it's for once. It's an exception.
Thank you. We are very happy that you took this paper seriously and really put this topic. I believe methane is one issue that is always needed still to remind, because in global public, the message gets the audience only if it's repeated. So it's not so simple as it sounds. You discover everybody accepts it and everybody makes now it's more complicated.
But we should also finish with shameless self-promotion. We are working on the new publication. This is the analysis of the EU methane regulation. So we plan to publish it as soon as the regulation is available. The final version of the regulation is available. I think many people, will be eager to read it because it's so complicated as a regulation, and I think there is a lot of expectation regarding the developments in Europe. So I hope that it will be a good one.
That's a cliffhanger to the next podcast. Well done.